1.1, apply properties of real numbers. A lot of what you see here is going to be a review from Algebra 1. In Algebra 1 and lower, you learned about rational numbers and irrational numbers. If you don't remember the difference between those two, you can go ahead and pause the video and read the difference. Our first example asks us to put two numbers on a number line. And it's kind of hard to put a number on a number line if you don't know which two integers it falls in between. A calculator might come in handy. For instance, if you type in -5/4 in a calculator, you're going to get -1.25. That helps us figure out exactly where to put this on a number line. Since we're at -1.25, we go a little bit further to the left than -1. And that's where -5/4 would be. Then square root of 3, that's a little harder to figure out unless you use a calculator. If you type that in a calculator, you'll get approximately 1.7, which we should know is a little bit between 1 and 2, closer to 2. That's how you plot numbers on a number line, even when you don't know exactly what they are without a calculator. Next example, standardized test practice. The table shows the lowest elevations of 6 continents. Which list shows the elevations from lowest to highest? Since we're asking for lowest, we want the one that's the smallest positive or biggest negative first. Since we've got a list of negative numbers, the first number on our list needs to be the biggest negative if we're going to go from lowest to highest. Looking at our answer choices, we can already throw out one choice, C. Our next number should be -156. Notice the rest of these all had -408. Our next biggest negative is -156. A has it, B has it, and D has it, so that didn't help us much. Looking at what's left, we have -86 as our next biggest negative. A has it, B does not have it, and D has it. So far we've gotten rid of half of our choices. Our next biggest negative is -40. A does not have it. D does. We don't even have to check the rest, but it doesn't hurt to if we have time. -28 should be next. -16 should be last. So our correct answer choice would be D this time. At this point, you can either pause the videos and do the guided practice now, or you can continue on with your notes. This next slide gives some properties of real numbers. The most important ones you'll see here are commutative, associative, identity, and inverse. Closure, you're not going to really use. Distributive is also important. Closure is more of a common sense one. It says if you have two numbers and you add them together, you get a real number. If you have two real numbers and you multiply them together, you get a real number. I can't think of any time I've actually quizzed or tested on knowing the word closure, though. The other ones you should know. Cumulative property says that you can switch the order when you add. Associative property says when you're adding three numbers, you can swap the parentheses to go around a different two numbers and it won't change your answer. The identity property says if you add 0 to a number, you get the same number. And the inverse property says if you add a number and its opposite, you always get 0. Similar properties are true for multiplication. You can look over those on your own. Distributive property says if you've got something multiplied by the sum of two numbers, so in this case I'm multiplying A times the sum of B and C, you just distribute the A to the B and the C. And we've seen that since before algebra also. Next example says to identify the property that the statement illustrates. So on part A, we've got two numbers added together. equaling the same two numbers added together but switched. That's an exact example of the commutative property. And you should say commutative property of addition, since there's also a commutative property of multiplication. Part B, it looks like we've got a number and its multiplicative inverse, meaning the same number but flipped, multiplied together to equal 1. If you look back at that previous slide, that's the inverse property. And just like before, we should say of addition or of multiplication. This time we're multiplying, so we would say of multiplication. That's it. Subtraction is defined as adding the opposite, something that probably don't really need to talk about. Reciprocal division is multiplying by the reciprocal. So you can rewrite any division problem, instead of saying a divided by b, you can say a times 1 over b. And you have to be careful that b is not equal to 0, because we all know we can't divide by 0. That's why b can't be 0 in either one of these equations. So we're supposed to use properties and definitions of operations to show that a plus the quantity 2 minus a equals 2. And we have to justify each step. This should remind you of a geometry proof. We won't be doing a lot of proof type problems in this class, but they come up once in a while. So we can start with what we're given. None of our properties deal with subtraction, so the first thing I'm going to do is rewrite that 2 minus a as 2 plus negative a. And that's just using the definition of subtraction. We saw that on the previous slide. I know that a and negative a cancel out to make 0. The problem is, using the properties, I've got to get the a and the negative a next to each other. So first I'm going to swap the 2 and the negative a. All I did from the previous step is switch the 2 plus negative a to a negative a plus 2. That's the commutative property. And technically we should say of addition, but I'm not going to write it on this. Next I'm going to move my parentheses around so that my a and my negative a are together. I'm allowed to move those parentheses around because of the associative property. I know a plus negative a is 0, so I rewrite 0 plus 2. That's the additive inverse. And lastly, 0 plus 2 I know is equal to 2. Forgot to write equal to each step of the way. And that's because of the additive identity, which says 0 plus anything is always equal to that anything. And we're done. Kind of like a geometry proof. We won't see too many of those, but we should always know why what we're doing is legal. Some more guided practice. You can either pause the video and do these now, or you can wait and do them in class. Next, we've got some unit analysis. We're going to use unit analysis with operations. Part A says you work 4 hours and earn $36. We want to know our earning rate. So if I'm earning $36 in 4 hours, I can either simplify that fraction or I can use a calculator. Either way, I'm going to find out that I'm earning $9 per hour. and that's an earning rate. Part B says you travel 2.5 hours at 50 miles per hour. It wants to know how far we go. So if we're going 50 miles per hour for 2.5 hours, we can say we're going 2.5 hours times 50 miles per hour. The units cancel. We're left with 2.5 times 50. You could put that into a calculator, or you can multiply it on your own, and we get 125 miles. Last one says you drive 45 miles per hour. What is your speed in feet per second? That one sounds a little harder to me. You start off at 45 miles per hour, 45 miles per 1 hour. We want to convert this to feet per second. Those of you who have taken chemistry are used to the idea of converting units. That's exactly what we're going to do here. It's called stoichiometry. If I want to convert feet per second, I want to get rid of miles. So one thing I might do is say, oh, I know that there are 5,280 feet in 1 mile. If you didn't know that, that's okay. I'd give you that information if I was going to test you on it and expect you to know how to use it. Miles are gone now. We got the feet that we need, but that's going to be feet per hour. We need feet per second. So continuing on, we'd say, okay, how am I going to get my hours to second? Well, I know if I want hours on the top, 1 hour has 60 minutes. And now my hour units cancel out. But I'm still not done because I want seconds, not minutes. Fortunately, we all know that 1 minute is 60 seconds. Now my minutes cancel out. Now I have to multiply everything that's on top by everything that's on bottom. No, I said that wrong. Multiply everything on top divided by everything that's on bottom, and I'll end up with my 66 feet per second, approximately. So we converted miles per hour to feet per second. Now for an applied example, we're going to use unit analysis with conversions. The problem says the distance from, I don't know how to pronounce all of these things, Montpelier, Vermont, to Montreal, Canada, is 132 miles. The distance from Montreal to Quebec is 253 kilometers. Notice the units aren't the same. We want to convert the distance from Montpelier to Montreal to kilometers, which really means we want to convert 132 miles to kilometers. Again, this requires a conversion rate that you might not know. I would give that information to you on a quiz or a test. There's 1.61 kilometers in 1 mile. That causes the miles to cancel out, and we're left with 213 kilometers. Part B is the same kind of problem, just going backwards. This time we're supposed to convert the distance from Montreal to Quebec to miles. We start with 253 kilometers. We can use that same conversion rate, 1 mile to 1.61 kilometers. Notice I flipped the fraction because I wanted kilometers on the bottom this time. And I end up with 157 miles. At this point, you can finish up the guided practice, or you can work on those in class. That's the end of this video.